We're now going to look at absolute value inequalities. First, absolute value of x is less than 3. If we recall back to what an absolute value equation was, it was just the distance away from 0. So here we would define absolute value of x is less than 3 as all values are solutions if they are less than 3 units away from 0. Versus absolute value of x is greater than 3 being in a similar sense. All values are solutions if they are more than 3 units away. From 0. We draw out our number line with 0 in the middle of 3 and negative 3. For the absolute value of x is less than 3, if we think about all the solutions that don't include negative 3 and 3 because we don't have an equal sign underneath the inequality symbol, then it would mean that it's all the values in between negative 3 and 3. So when we write our inequality, we would say, well, our values are less than 3 and greater than negative 3 at the same time. And because of that, we can summarize it as a compound inequality. What a compound inequality is that we would, instead of writing it as two separate inequalities, write it as a single inequality with less than symbols on either side of x. And on the right, you would have that x is less than 3. At the same time, it's greater than negative 3. And that would represent all your solutions. As opposed to the greater than, if we take a look at the number line for the greater than, you have that zeros in between 3 and negative 3 on our number line. And we don't include 3 or negative 3. And our solutions this time are distances that are greater than 3. So that would be on either side, to the right of 3 and to the left of negative 3. So if I pick any random value here, let's say 4, 5, 6, or negative 4, negative 5, negative 6, that if I take those values, plug it into an inequality, the absolute value inequality, I would get an absolute value back of positive 4 or 5 or 6, and those values are greater than 3. So to summarize our solutions with this, we would write our inequalities as x values of x that are greater than 3 with the keyword being or between our inequality and x is less than negative 3. So there's no way of writing the or as a compound inequality. Compound inequalities only summarize our and situation, which brings us to a interesting way of remembering that, the and versus the or. So with that, I'm going to summarize this in a different color, where when you think of the phrase less than, the tail end of then is an, and if I add a d, we have that keyword there being and. So with absolute values that have less than, your final solution will have the word and between the two inequalities versus greater. But instead of thinking of greater as ER, I'm going to replace the E with the O and then end it with the R. So keyword of or now is repeated over here between the two inequalities. That's one little trick you can use to remember the difference. Now let's go ahead and go over some more complicated examples. On example number 1, we're going to solve that 2 times the absolute value of 4x plus 1 minus 5 is less than or equal to 1. We want to keep in mind if we're solving for inequalities or equations with absolute values in it, we're going to first isolate the absolute value expression. So with that, we're going to add 5 on both sides, get 2 absolute value of 4x plus 1 is less than or equal to 6. to undo times, we would divide. Absolute value of 4x plus 1 is less than or equal to 3. And then it's at this point that we're going to use that trick. So if this is a less than symbol, then that means that my final solution is going to have the word and between. It's going to be a compound inequality. So the first inequality I'll set up is going to use the absolute value expression that's inside the absolute value symbol. We're going to take that, remove the absolute value symbol, take the less than or equal to symbol that we have right there, and then the 3 on the right. Keep that the same. Then go ahead and solve. One of our solutions is going to be x is less than or equal to 1/2. Now the other part that the other inequality I'm going to set up, it also starts, so this is the part that some students will make a mistake on. You want to keep the absolute value expression inside the absolute value symbol the same. We're not going to negate that or make that negative. We're going to keep it as 4x plus 1. What we are going to do is, and I'll just kind of show you guys, we're going to flip, these are the changes we're going to make. We're going to flip the inequality, make it greater than or equal to here, and then we're going to negate that number on the right and make it -3. So if we now continue to solve, we have 4x is greater than or equal to -4. X is greater than or equal to -1. So let's go ahead and carry down that word, keyword and in between, and then draw this on a number line. On a number line, it's greater than or equal to -1, but less than or equal to 1/2. So the equals to would mean that we would have a solid circle at -1, a solid circle at 1/2, and our shading would be in between that. And we can also write our answer as a compound inequality where we would put x between the less than or equal to symbols, have on the right the greater number, so less than or equal to 1/2, but greater than or equal to -1. And that would be our solution to example number 1. For example number 2, sometimes our situation is going to result in some unique results. So in this case, you have -2 times absolute value of x plus 4 is less than 22. So same first step, we go ahead and divide both sides by -2. So here I'm going to change colors and make a note. Remember that when you guys are solving inequalities, you flip the inequality symbol when multiplying or dividing by a negative number. So in the above example, you guys are dividing by -2. So the result of that would mean that your absolute value of x plus 4, we keep that still. We're going to switch our absolute, so it's circle in the same color. Switch the inequality. Let's keep it the same color. Greater than or equal to -11. Not equals to, just greater than -11. And then our two inequalities that we set up would have the expression on the inside, and then maintain, for the first one, maintain the same direction of the inequality, and then -11. When we base our keyword on the inequality symbol, it's going to be on it after we've already isolated the absolute value expression. So here this is greater, so we're going to use the word or in between. And then we'll finish off setting up our second inequality as x plus 4. Flip the inequality symbol and then make it the opposite. So now if I continue to solve the rest of the way, it's x is greater than -15 or x is less than 7. So on a number line, x is greater than -15 or x is less than 7. Okay, so so let's think about what that means. If it's greater than -15, it could be any solution. Let me put a open circle here, could be any solution greater than negative 15, which is over to the right, or any solution less than 7. So pick any number. Let's think about this a bit. If I pick 8, is 8 greater than negative 15? Sure it is. It doesn't say it has to be both greater than negative 15 and less than 7. It just says or. And so that's going to be when that keyword matters. And the step that you want to use to make that determination is right here after you've already isolated the absolute value equation. So that means that every number on that number line is a solution to that inequality. So we want to say that all our answer actually is all real numbers. All values on that number line work.